Good evening, friends. Today we are going to discuss about electromagnetic induction, Fleming's right hand rule, and electric generator. This is the continuation of the first part, that is, the topic name was electromagnetism. So I suggest you all to study the first part, then come to the second part because both are interrelated. So let us start. What is electromagnetic induction? Electromagnetic or magnetic induction is the production of an electromotive force, that is voltage, across an electrical conductor in a changing magnetic field. As taught to you in earlier class, when a current carrying coil is placed in a magnetic field, it experiences a force, and that moving magnet will produce some current, as told by Faraday. So now let us give us an example. Now let us imagine a situation in which the conductor is moving inside a magnetic field, or a magnetic field is changing around a fixed current. Here our assumption is that this is our fixed current and our magnetic field will move. We have considered one bar magnet. There is a permanent magnet, a conductor where we have wrapped some coil, and we have used one instrument known as galvanometer. Now what is galvanometer? Galvanometer is an instrument that can detect the presence of current in a circuit. With the help of a galvanometer, we can detect whether the current is present in a circuit or not. At null position, there is normal position. This is a zero position. When it is straight, it is the zero position. That means current is not flowing in this circuit. Whenever it will move towards the right side or towards the left side, then we can say that current is flowing in this circuit. Now let us assume that whenever we try to move this bar magnet, we see some deflection in this galvanometer. This shows us that some current is being induced in this coil. Now whenever we try to move this bar magnet towards south side, the galvanometer moves towards the left side. This indicator will move towards the left side, and whenever we try to bring the bar magnet close to the conductor or close to or towards the north side, then this galvanometer indicator will go in the right hand side. This shows that current is being produced in this circuit. Now in the second example, instead of bar magnet, I will consider one electromagnet. That means due to change in current, an magnetism will produce in a conductor, that is known as electromagnet, which I have already discussed in the first part. Now let us begin. This is our second example. This is two coil 1 and coil 2. In coil 1 we have shown a battery, a switch, and in the second coil we have given a galvanometer. Whenever there is a change in current, there is a change in magnetic field lines, then because of that, this galvanometer pointer moves towards the right hand side or towards the left hand side, which shows us that current is being induced in this second coil, and this is known as induction, electromagnetic induction. With the help of the coil 1, due to the change in current, we are producing current in a second coil, which is known as electromagnetic induction. And the induced current will be maximum when the direction of the coil is in right angle to the magnetic field. Because of that, we have used the term known as Fleming's right hand rule. With the help of Fleming's right hand rule, we can find the current induced in the conductor. Here we have considered a thumb finger as the movement of conductor, that is motion. The forefinger, that is this finger, we have considered as magnetic field lines, and the middle finger, this finger, we have shown as current induced in the conductor. You must always keep in mind that the magnetic field, that is in the forefinger and the middle finger, always must be perpendicular to each other. And for that, I have found a small trick which might be helpful for you. You may remember it like this: FMC. F means father, M means mother, and C means child. F stands for force, that is thumb will represent it. M stands for magnetic field, that will be represented by the forefinger, and the middle finger will be represented by the current. So you can remember it easily: father, mother, child. That means this is the position. This thumb will show the father, mother, and child. It will be easy for you to understand that, and you should always keep in your mind that we use Fleming's right hand rule in generator and Fleming's left hand rule in motor. And now we are going to discuss about electric generator. What is electric generator? An electric generator is a rotating device that converts mechanical energy into electrical energy. It is the opposite of motor. The input will be mechanical and the output will be electrical. Where in case of motor, the input was electrical, the output was mechanical. The construction is same. The only difference you will find in the direction of current. And instead of battery, we have shown you a galvanometer. This will indicate whether current is being induced in the coil or not. We have considered two bar magnets, north pole, south poles. These are the field lines, that is magnetic field lines. A, B, C, D is the rectangular coil which is being connected to a axle mane thura, where this red color are the two slip rings which is represented by R1 and R2, and B1 and B2 are the brushes which are the stationary part connected to the galvanometer. Now we have to move this axle mechanically from outside to rotate the coil, and in practical case it is rotated with the help of prime mover or any other means. So the outer ends are brushes. This B1 and B2, I have already said that these are brushes, and we have used a galvanometer to detect the flow of current. Now A, B, C, D is rectangular coil is rotated clockwise. By applying Fleming's right hand rule, the induced current are set up in the coil. In the first half, when the rectangular coil ABCD will be rotated like this, due to which A and B will move upwards and C and D will move downwards, and because of this movement the galvanometer will deflect, and which means that current is being produced in the rectangular coil, sorry, not rectangular coil, in the circuit. In the second half, the diagram will be like this, where now second half AB will go this side and D and C will come this side. In the second half, again the same principle, it will be rotated clockwise. Again this C and D will portion will go upwards and AB will go downwards, and this will keep moving. This will be continuously done. In every half cycle the direction of current keeps on changing, first like this, first positive, then negative, positive, negative. And because of that, when the direction of current keeps on changing, then there will be a production of AC current. When the direction will be in the same direction, then it will be a production of DC current. Here, as I have told you, the direction is changing. One time it will be positive, another time it will be negative, and because of that AC current is being produced here. If you want DC current, then in case of this slip ring, this one known as slip ring, I have told you are in earlier classes also, instead of slip ring we use commutator, then there will be production of DC current. But here we are using slip rings, that's why there is a production of AC current. And the direction of induced current in both arms change, giving rise to induced current in the direction DCBA, which I have already showed you. This AC current always changes its direction in every 0.02 seconds. In every 0.02 seconds the direction will be keep on changing, and because of that we get AC current. And the frequency of this is 50 Hz, and the formula is F is equal to 1 by T. T is the time period. You must know that I am just giving an example. This is not required to you now. What do you mean by DC? DC means unidirectional straight. This will always straight line. But in case of AC, it will be up, down, and this is the waveform of an AC current. This is the waveform of a DC current. This is not required to you at present, but still I am showing you what do you mean by change in positive, negative. This side will positive, negative, positive, negative. This will keep on changing, which will give us AC current. But here it is unidirectional, means it is flowing in one direction only. This is known as DC current. And for the production of DC current, we will use commutator here, not slip ring. If we use slip ring, then there will be production of AC current, and if we use commutator, then there will be production of DC current. So that's it. Thank you.